Do you remember the last time I built a rocket and it flew up into the sky, did a few donuts, and then violently crashed into the ground? I built another one. This is Grapefruit 2.0. If you remember from the last rocket, there were a few issues, but I've solved all those issues to the best of my ability, and I've added so many new features. Let's start by talking about the thrust vectoring mount. This is the part that failed on the last rocket in the middle of the flight. What happened was the adapter from the 29mm mount to the 24mm mount broke in the middle of the flight, which made the rocket engine slide up further into the mount, and it knocked one of the servos out of place. This time, I 3D printed a brand new thrust vectoring mount, and instead of using an adapter from the 29mm to the 24mm, I just made it so that the mount was made for a 24mm engine, so that the mount couldn't break. Now, you can see that the mount walls are so much thicker, and it can't slide back. And in the back of the mount, there's a solid inch of hot glue, so I don't think the rocket engine's breaking through that. Another new feature of this thrust vectoring mount is that it uses stronger servos. The servos that I were using before were the classic 9-gram servos that had plastic gears and weren't that strong. But now I'm using metal-geared, stronger servos to control the thrust vectoring mount. Now, it took me a little while to decide on the thrust vectoring mount that I was going to use. At first, I decided I wanted to design my own, since the first one I downloaded from Thingiverse. This here was my first design. I was just trying to get the gimbaling parts down, and it worked pretty well. Then I moved on to this second version, which is much more advanced. It's got sides that can connect to the airframe, and a top part for the servos to go. So, I tried again, but this time I just couldn't get my idea to work. To try and make the idea work, I ordered these servos. They're super strong and they're metal geared inside, which means they won't wear out. I tried them, but just still couldn't get the idea to work. So after I couldn't get my thrust vector control mount to work, I decided to go back to another design that was a bit closer to the original. But I printed it with the wrong filament and it was super breakable. I'm really excited about this new mount, and I hope it works better than the old one. Going down the rocket, you see two wires. These wires are really cool because there are igniter wires. It means that the rocket ignites its own engine, which means I don't have to stand out in the middle of the field right next to the rocket when it goes off. These wires lead up the rocket and into the flight computer. The flight computer is the thing that's gotten the most work since the last rocket. There's so many new features that I want to tell you about. Let's start with the rocket ignition system. On the flight computer, I added a Bluetooth module which connects to my phone. From my phone, I can tell the rocket to launch. When the rocket detects that I've told it to launch from my phone, it sends a message to a relay at the bottom of the flight computer, which opens up the relay, which allows 9 volts to pass through and ignite the rocket engine. This is super cool, and I'm super excited to launch it. This is one of the tests that I ran. The test shows the flight computer igniting the igniter. Another feature that I added to the rocket was a state indicator light. The light turns green when it's in its powered flight state, and it turns red when it's in its idle state or its descent state. This light allows me to better know what state the rocket's in so that I can troubleshoot while testing. It just makes it a lot simpler. Along with the LED light, I also added a buzzer. This buzzer goes off to indicate the countdown. The countdown allows you to know how long until the rocket flies off, and it's super important. The flight computer also got a massive software update to accommodate all of the new features, and also because some of the old software wasn't working. For instance, before, how I was detecting the parachute deployment wasn't very reliable. I was using the barometer to see if the rocket was going up or down, and if the rocket was going down, then I would trigger the parachutes to deploy. The barometer is super inaccurate, which means that it wavers by about a meter, so it's difficult to know whether the rocket's actually going down or if it's just the inaccuracy of the barometer. So now, instead of trying to detect if the rocket's going up or down, I just have a timed system that's the exact amount of time that the rocket needs to burn out its propellant and start to fall. Then the parachutes will be deployed. This makes it so that the parachutes don't get deployed too early or too late. And if we continue up the rocket, we have the parachute ejection system. It's pretty much the exact same as it was before, except now we're using one of these stronger motors. Otherwise, the parachute ejection system is exactly the same. The servo turns and pulls this half of the nose cone off, and along with it comes out the parachute. I'm super excited that the rocket's finally done. It's taken multiple months, and I'm super happy that it's purple. Hopefully I'll be able to launch the rocket in the next couple of days, but we'll see how the weather is. After I launch this rocket, I'm going to be making Grapefruit 3, which probably will have a ton of cool updates. I'm also planning on building a launch pad, which will be super cool. Hopefully you stick around for that, and I'll see you later.